Hello students, welcome to the heat transfer lab. Today we are going to discuss about experiment number 5, that is the heat transfer through fin apparatus. Okay, before dealing with this experiment, we'll have a bit of discussion about what is meant by fin. Okay, so already you know that what is meant by fin means it is some extended surfaces which are used to increase the rate of heat transfer between a surface and adjacent of the fluid. And fins are classified in different way. Variety of fins are available in the market. It may be triangular fin, rectangular fin, pin fin, circular fin. Okay, so usually the triangular fin are fixed to some cylindrical objects or surfaces. Some for the pin fin kind of apparatus fins are used for plane surfaces. Okay, we'll discuss what is the aim of the experiment and how to conduct this experiment. Okay, so aim of the experiment is to determine the efficiency and effectiveness of the fin by forced convection using pin fin apparatus. So here we are going to find out the efficiency and effectiveness of the fin by using forced convection. You may know that already there are two types of convection by Newton's law of cooling. One is natural convection, or we call it as free convection. Another one is forced convection. For example, forced convection means if you have a hot plate, if you want to cool it in a faster rate, you are using some external agency or energy source, that like fan, to increase the rate of cooling. Because you are utilizing some energy. In case of natural convection, for the same plate is exposed to atmospheric air, it is also cooled down, but it takes time, but we are not using any source of energy. So this is the time difference between the natural convection and forced convection. Okay, so what is meant by efficiency? In general, I can tell what is meant by efficiency means, while efficiency refers to how well something is done, but in case of effectiveness, it refers to the how useful something is done. Okay, example, if the car is there, okay, it is very effective form of transportation. It can able to move people from across long distance from one place to another place in spite of whatever the distance. Specific places it will take over these people. But a car may not transport people efficiently, but it can, how it will be useful. Correct? So this is the difference between effectiveness and the efficiency of the systems. Okay, in the same way we are going to find out in heat transfer, related to the heat transfer to the fin, we have an equation to find out efficiency and effectiveness. Effectiveness can be calculated by using formula epsilon is equal to mk tan hyperbolic ml by h, and efficiency is q fin divided by q ideal, means the ratio of actual heat transfer through fin to the ideal heat transfer through the fin if entire surface where fin is at a base temperature. Okay, so these are some specifications they have given for the designer of that equipment. They have specified some dimension or parameters, so they are given here. And this is a observation. In observation, we have to note down voltage in volts, and current in amps. We have to observe and we have to note it down. And manometer reading H1 and H2 also is given. And the tabular column is given for various temperature readings for the pin. The fin is having some length. So at different position of that fin, they have attached some thermocouples. So at different points of fin, the thermocouple reads the temperature in digitally. That temperatures they have given T1, T2, T3, T4, T5, T6 at various instant of time given. Okay, for every instant 5 minutes, for every 10 minutes or 15 minutes, what will be the temperature changes in the fin. Okay, next. So these are some formula to find out efficiency and effectiveness of the fin. So finally this formula we are going to use, that is neta is equal to tan hyperbolic ml divided by ml, and epsilon is equal to underscore root of kp divided by ha into tan hyperbolic ml. Okay, these are all theoretical part how we are going to calculate it, but how we can run the experiment, how we can start the experiment. So here some procedure is given. So first what we have to do, after making sure the dimmer stat and blower should be off, and use the switch on the mains. Okay, so before switch on the mains you must observe that whether dimmer stat and blower off or not, that you have to take care. Second one is switch on the temperature indicator and check whether all the thermocouples readings are correctly it reads or not, that you check it. And third one is switch on the blower, set the flow control valve for full opening. Okay, there are valves are there, so off 1/3, 1/4 like that. You have to opening the valves. Based on that, the air will be flow through that blower. Okay, so you have to kept it as full open valve. Okay, and fourth one is adjust dimmer stat to give power of about 90 to 110 volts. So we have to keep or adjust dimmer stat in such a way that it should be 90 to 100 in that range. Voltage should be in that range. And fifth one is note down all thermocouple readings every 10 minutes until it gets a steady state. After making sure voltage is ready at prescribed reading, you used to stop it. Okay. Next, sixth one is a steady state is take down the thermocouple as well as the manometer readings, and use steady state readings for the calculations. So where the values are getting steadily, you are getting the values, so that value you have to consider for the calculation. Then cut off power of the to the heater, and after whole shutdown the blower and main should be switched off. Okay, this is the procedure for conducting the experiment. So once we get the data and calculations is done, so we have to write down the values, result of that efficiency of the fin and effectiveness of the fin. So both are utilized quantity, only it is a number. You should remember that. Okay, I hope you guys you follow these instructions of this how to conduct the experiment of fin apparatus. So we'll move on to the conducting of experiment in the next video. Thanks for watching. Hello students, welcome to this heat transfer lab. Today we are going to conduct the experiment on fin apparatus. So let us discuss what is meant by fin. Already you know that fin is nothing but it is an extended surface. Okay, anything you extend the surfaces or wider the area, it is increase the rate of cooling. As you know, according to Newton's law of cooling, the Q is equal to HA delta T. As A is the direct proportional to the rate of cooling. As higher the area, higher the rate of cooling. So lesser the area, less cooling. Likewise, so here also you have observed that in IC engine the body is having the extended surfaces. Okay, like even though compressor, even transformer. So where it is a high temperature is going to be reduced, so we are going to extend the surfaces. Even if you see naturally, if you take a cup of tea or hot plate, the hot plate you take exposed to the atmosphere, what happens? It will be cooled down, but it takes time. But in case of for the same hot plate, if you take it over a fan, so it blows some air onto the plate, what happens? Suddenly the rate of cooling is increased because you are forcing the area, forcing the air to cool the object. Okay, even similarly for the increasing the area, you will get the rate of cooling is more. Okay, let us discuss step by step how to conduct this experiment. Here initially you have to switch on the main, and this experiment is consists of dimmer stat, voltmeter, ammeter and temperature readings. Okay, and this is the blower main, okay, and this is the blower as you have seen here at the bottom of this, the blower, and this is the duct, okay, this is the duct, spiral duct will be there, you can see here, the duct is like this. Even you can, if possible, you can see the pin. It is positioned in this way. So the fin inside at this point, the fin is positioned like this. So at various points of this fin, so the thermocouples are connected here. See here, the fin is like this inside. So the thermocouples are connected at various points. So the temperature we can read out in this. And this is the blower valve. We have to keep it on this blower valve, and this is the exhaust, the outlet air to this blower. Okay, let us we'll start the experiment. So first step is we have to observe it should be in 0 position. So already we have started and given heat, sufficient heat to the fin. So we'll start directly. Okay. So we have to make it thermostat. It is around 110 or 120. Okay, corresponding that voltmeter will get the ammeter readings. Okay, so now I will switch on the blower. Before that switch on blower, I have to open fully this valve. Okay, so I will open this blower fully on, open, so that the complete air will be taken into this. Okay, I will start the blower now. Okay, now we start to take the readings. Okay, so here the tablet column. Okay, so we have to take down the readings at various temperature. While when it is on, only we have to take this temperature readings. See, you can see the various temperature on the thing. So. Okay, by operating this, now we will get the temperature, but actually we have to wait for sufficient heat to taken into the fin, then only we will get the proper reading. Okay, so once we get the readings, you have to enroll these values. So until you will get the steady state condition. For every time step or 10 minutes, you will take the reading. Once we get the steady state, that value you consider for the calculation. These are all the formula as we already discussed in the presentation. So use this formula to get the natural convection, that is H, we are going to find out. So one is efficiency, that is already you know efficiency neta we have to find out, and another one is effectiveness by using the formula and the data which is getting from the experiment. Thanks for watching this video. Welcome to the heat transfer lab. Now we are going to discuss the topic experiment on heat transfer through pin-fin apparatus. Okay, before going to this experiment, we must understand what is meant by fin. Fin, already you know that it is an extended surface. From this experiment, we are going to calculate, so determine, the aim of the experiment is to determine the effectiveness and efficiency of the pin-fin. Okay, here the observations are given like this: voltage and current. So voltage and current we have to note down from the experiment. So once we note down the experiment of the values, so voltage and corresponding current, so manometer readings also will be there. That is H1 is 0.0 mm, 2 mm and H2 is 16 mm. So we will get the difference manometer reading, that is 14 mm. The next tablet column. So tablet column, so there are 6 thermocouples are connected to the pin fin. So that readings are like this with a time lapse of every 5 minutes, 5, 10 like that. So the first reading for 5 minutes is 48, 45, 39, 40, 37, 33 degrees centigrade. So I have taken for the last one, that is 30 minutes, because it is almost steady state. So we have to consider for the calculations. Those readings are 110, 103, 74, 74, 71, 33. Okay. Now once we got this steady state condition of the readings, temperature readings, we are moved on to the calculation part, that is TMF, mean film temperature, that is 110 plus 103 plus 74 plus 74 plus 71. Okay, that is T1 plus T2 plus T3 plus T4. Okay, plus T5. So these readings we have to take divided by 5 and we will get 86.4 degrees centigrade. Once if we got this, and you have to calculate TMA. Okay, so TMF plus T6 is nothing but by 2 is equal to 59.7 degrees centigrade. Okay, next. So we are going to calculate area. So pi by 4 d1 square is the diameter of the diluted pipe, 3.6 centimeters, and pi by 4 d2 square diameter of the orifice, that is 1.4 centimeters. So now you have to do at exact 33 degrees centigrade, you won't get any fluid property from the data handbook. But here we got 33 degrees centigrade. At that temperature, we have to find out kinematic viscosity, Kirchhoff number, Prandtl number, density, thermal conductivity, all properties we have to find out. Okay, so these are the values from the data handbook. The 33 lies between 30 and 40, so we have to note down the values from the handbook. And here also for thermal conductivity and Prandtl number also we have to note down. Once if you note down these values, we have to calculate one by one. First one, that is mu by interpolation method. So we can calculate kinematic viscosity by interpolation method, x2 minus x1 divided by x minus x1. This is the general formula for calculating any intermediate values. So we got it. Mu is equal to, so this is mu is equal to 16.28 into 10 to the power minus 6. Similarly, for the density of the air, we got it 1.39 kg per meter cube. Similarly, thermal conductivity, that is 0.029 watt per meter Kelvin, and Prandtl number will get 0.6996. So once we got all thermal conductivity, density, and kinematic viscosity and density, so you substitute to calculate heat transfer coefficient. So before going to heat transfer coefficient, you have to find out what is the head. So HW, head of the water, in density of the water divided by density of the air. So you will get head of the air, you get it. So there is a 131.628 meter. So now you calculate omega, the CD into A1 A2 under square root of 2GH divided by square root of A1 square minus A2 square. Substitute all these values in this above equation, you will get 5.06 into 10 to the power of minus 3. Once we got this value, find out area of the duct, that is L into B. So you will get 0.015 meter square. Then velocity of the air, that is at T6, is nothing but ambient temperature. That is value is omega divided by area of the duct. You will get 0.337 meter per second. That is velocity of the air. You will get 0.337 meter per second, and velocity of the air at Tm is going to calculate, that is 0.3373 into 59.1 plus 273 divided by 33.273. You substitute these values, you will get velocity of the air. Okay, so that is 0.36 meter per second. So next, Reynolds number, you have an equation, Reynolds number, that is R is equal to VMA into DF divided by nu A. So substitute all these values, you will get Reynolds number 284.18. Okay, 18. So and the Nusselt number is 0.615 into Reynolds number to the power of 0.466 into Prandtl number to the power of 1 by 3. So you will get 7.595. And heat transfer coefficient is nothing but Nusselt number and thermal conductivity divided by dF. You will get 16.147 watt per meter square Kelvin. So this is the heat transfer coefficient. Then we are going to find out M. In the equation it is required. Okay, so before that, perimeter is pi d, So here D is the diameter of the fin, that is df. So pi into df is 0.0398 meter, that is the perimeter, and m, the constant value, that is m, that value m is equal to under square root of hv by ka. So that is 0.771 meter. So once if you get the value of m, so you can calculate efficiency. Efficiency of the fin is tan hyperbolic ml divided by ml. Tan hyperbolic of 6.77 into 15 into 10 power of minus 2 divided by 6.77 into 15 into 10 power of minus 2. So we'll get 76.30 is the efficiency of the fin we'll get. So finally the effectiveness of the fin is under square root of kp divided by HA into tan hyperbolic ml. You'll get effectiveness is 35, that is 0.35 is the effectiveness of the fin. So thanks for watching this video.